Okay, guys, so I'll say that I was compelled to make this video because it seems like a lot of people have been getting this wrong, and not only because they, didn't know the answer, but for a worse reason, which is that everybody seems to be copying down the same answer from somebody whoever it was, somebody who didn't know the right answer, and I don't know what their logic was, but it's pretty off. And I have the answer that everybody's been copying down so far in front of me, so I can read it here as I go along, but. In any case, so I want to say there are two things that you can kind of look for that make it a whole lot easier to identify what device is in front of you. Oops. Okay. The first thing is to look for slip rings. Okay. So in the image here, there are only two rotors that have slip rings. We have this one here and this one here. Okay. These are slip rings. All right. The other thing to look for is just to look at the core. These over here. These are the rotor cores, and to see first of all if they're wound or not. And then if they are wound, how are they wound? Okay, these are two things that make it super easy to identify any rotor that is in front of you. Any, like a big industrial machine or a tiny DC motor or whatever, these make it like super easy to identify these rotors. Okay, so it's not hard. All right. So all right, let's look over here. This first one. First of all, it has two slip rings. Okay, right away, the only rotor that has two slip rings is a synchronous machine rotor. Now there are two types of synchronous machines. There are salient pole rotors, synchronous rotors, and non-salient pole or cylindrical synchronous rotors. Now it's kind of hard to tell because you need to be able to see the windings over here. If this was cylindrical, then the windings would kind of go like this, okay, like along the axis of the rotor. But if it was salient, then the windings would kind of go like this, perpendicular to the axis, okay, kind of coming out of the page almost. And depending on the number of poles you might get, say if this was a two-pole salient pole rotor, then you'd have two windings that kind of go in opposite directions like that. If this was four poles, you might have one winding like that, one winding like that. But just looking at the image, it's hard to tell. Which comes to my first point on that answer that people have been copying down. Verbatim, it says something like this. The first one is a salient pole rotor because there's a visible plus shape in the center of the rotor along the axis. I really can't see what plus shape is being mentioned here. I really can't. And also a plus shape at the center. I mean, it's not a great reason to say that this is a salient. I mean, if it was a salient pole rotor, it might have a plus shape. But if the salient pole rotor had 6 poles or 8 poles or what have you, it would not be a plus shape. It'd be, something like that. So that's a bad reason to say that this is a salient pole rotor. Also, I really can't tell that there's a plus shape. I honestly wouldn't know. This could either be a cylindrical or a salient pole rotor. I will say at least that synchronous rotors tend to be salient pole for the most part, okay? But cylindrical ones are easier to analyze. So anyways, this one, synchronous, okay? Synchronous, that's at best. And maybe you can say it's salient. Okay, let's go to this next one here. What did the answer that people have been copying down say? The answer said that this was an induction, a wound induction rotor. Or let me see, sorry. No, sorry. This one is a cage rotor. For this one here. And they said that people said that they found this on YouTube or Google, or they saw images just like this. First of all, this is a DC rotor. Like this is like 100% DC rotor. There's no doubt about it. You see this here? That's a commutator. And that's kind of in the problem statement, okay, over here that I mentioned, that this commutator here will be on one end of the shaft, and it's at least half the size of the rotor's core, so it's pretty obvious. And it also, the DC rotor looks a lot like the core section of a wound induction rotor. So it will have windings, that's first of all, and you can see that here. And also, there is this big ass thing over here that is half the size of the rotor core and is on one end, and it's pretty clear that this is a commutator. There's also, if you went into a little more, commutators have these, slits over here like that. These are what connect to the brushes when you're feeding in DC to the rotor. The brushes connect to these slits, and each of these slits are through the windings, and so the slits are alternating in such a way that you can get alternating current in the rotor, and that's what causes rotors to run to begin with. Anyway, so this is clearly a DC rotor. Okay, it is definitely not a cage rotor. I don't know why people would say this. First of all, cage rotors do not have windings. Okay, there are windings here all over. So clearly, this is not a cage rotor motor. Also, cages look a little. They do not look like this. They look a little different. Okay, they'll have this kind of arrangement. Okay, that's how like straight, not slanted like that. Okay, so there are several reasons why this is not a cage rotor induction motor. Okay, so this is 100% DC. This one over here is maybe hard to tell. If you were trying to look at the core over here, it's not easy. This could be, maybe this could be this. You know, they look a lot alike, these two. However, one dead giveaway, and first of all, this is a cage. This is the cage rotor induction motor. Okay, so this is the cage rotor. The one dead giveaway is there are no slip rings. You cannot see any slip rings here. Okay, also I should say, I mentioned in the question, these dark rings, they are not slip rings. They are, you know, I don't know what you call them, but mechanical brackets, let's say, or something like that, to hold the rotor core in place so it doesn't kind of like move back and forth. So it holds it in place, but these are not slip rings. Okay, slip rings are these things. Okay, those are slip rings. But in any case, there are no slip rings on this, and there's only one rotor that does not have slip rings, and that's the cage rotor. And that's because it does not need slip rings. The field current going into these kinds of rotors are induced into them via transformer action. Okay, so yeah, the answer that people have been saying is this is a non-salient rotor because it is it's very similar to this one, except it's cylindrical. I guess that's not terrible reasoning if you thought it was similar to this, but here's the thing, this is not a synchronous machine because there are no slip rings. If there are no slip rings, there is no way to give this rotor field current. And without field current, you can't have a synchronous machine. Okay, it's kind of the opposite of a synchronous machine. So definitely not a synchronous rotor or a cylindrical one, whatever it is. This is a cage rotor. It's not easy to see the cage thing, like I mentioned, and that's the thing. Sometimes the cage is covered by something like this over here, for example, some extra casing on top, but because there's no slip rings, this is definitely a cage rotor induction motor. Finally, this is the wound induction rotor, and it's you can kind of come to this by seeing that this is the only one left. Okay, these are all different rotors, and this is the only one left. The only thing we haven't kind of mentioned is the wound induction rotor. Okay, so that's one way you can see this. Another way you can see this is there are 3 slip rings over here. Or sorry, at least 3. There are 4. It looks like 4. I'm not sure why there are 4, but for sure this is more than 2. And so this is definitely not a synchronous rotor because synchronous rotors have just 2. And the only other thing that has slip rings is a wound induction rotor. And if you remember from the previous lab, these slip rings allow you to change the resistance of the windings here, which allows you to change torque speed characteristics, okay, of this machine. So this, just that alone should tell you that this is wound. Also, obviously, there are windings here, okay, and there's only there are only two machines that have windings that go kind of parallel like that, okay. And also in the problem statement, I did say the DC rotor looks a lot like the core section of a wound induction rotor. If you concluded that this was a DC rotor, the other core that looks a lot like it is this one over here, so this has to be the wound induction rotor. I mean, there are several ways that you can come about concluding that this is a wound induction rotor. Anyways, and I will say that the answer people gave was that this was wound because, okay, and this is fine so far, this answer. The final rotor is wound because of the way the windings are presented at the end of the stator. And see here, and let me see the other one. Yeah, at the end of the stator. This is a rotor. There is no stator here. I don't understand why. I mean, goodness, at least know that these are all rotors and there's no stator present whatsoever. There's nothing that's stationary, going to be stationary in the machine. The stator is the stationary part of a electric machine, and it's the thing that you feed 3-phase AC into, for example, for AC machines. None of these have stators on them. These are just the rotor parts. Okay, so there is no stator here. So please, that's just a big no. So anyways, hopefully you guys got the basic idea of how you identify rotors here. This is pretty much all the kinds of rotors that you will see. in the real world. Obviously, there's the universal motor, and there are other types of motors that we haven't covered in this class, but I just wanted to say that, for the most part, you're going to see these. So please, at least be able to identify rotors when you see them, because that's the first step in working with these things. And if you can't even identify the device you're working with, not only will you not be able to work with it, but if you misidentify it, you could end up damaging it or worse. Okay, so please get this right. And next time, please give it a try when you try and answer a question. Do not copy an answer. Or if you're going to copy it, make sure that it makes sense. The answer given does not make sense. It's completely off, and I'm a little bit upset at whoever put this up, because they not only are spreading spreading false information, but they're just showing a complete lack of knowledge on this topic. So, anyways, I just wanted to put that up. Okay, so with that said, I hope you guys enjoy your summer, and all the best with this quarantine. And I know that this is the end of the semester, so most people are just trying to get through and finish up the lab. So I get it. So all the best. But anyways, yeah.